In this lesson, we'll use the formula that we derived previously for dy dx to do an example in which we find the equation of the tangent line to a polar curve. Here we have the polar curve r equals 2 minus sine theta, and I've graphed the polar curve for you here. And we're asked to find the equation of the tangent line at the point where theta is equal to pi. So the first thing I'm going to do is just sketch in the tangent line that we're looking for. So we know that when theta is equal to pi, our r is 2 minus sine theta, so 2 minus sine pi, which is 2 minus 0, which is equal to 2. So I find my theta equals pi angle, which is the negative x-axis, and I know my radius is 2, so I count out 1, 2 from the origin, and here's the point that we're interested in, and again I'm just going to sketch in roughly what our tangent line looks like. So we want the equation of this tangent line. Recall that to find the equation of a line, we need a point and we need a slope. So if m represents the slope of our line and x1, y1 is a specific point on our line, then we can use the point slope formula, which I have here, to find the equation of our line. So remember that for a tangent line, this slope m is just dy dx. So we need to find two things. We need to get our dy dx and we need to get our point on the line. So I'll start by getting our point on the line. So we remember that our point, the x-coordinate, is r cosine theta. We already found our r, it's 2, and our theta is pi. So we're getting 2 times cosine of pi. Cosine of pi is minus 1, so our x-coordinate is minus 2. And again, we can see that from the graph. In terms of the x-coordinate, we're over 1, 2, so we're at minus 2. And what about the y-coordinate? Well, again, from our graph, we see that it should be 0, but let's just go ahead and verify that with our formula. So we know y is our sine theta. Our r we found to be 2. Theta is pi. Sine of pi is 0. So we get 2 times 0, which is equal to 0. So our point is the point 2 comma 0. And so now for our slope, we need dy dx. So we remember the formula that we just derived previously for dy dx for a polar curve. And if you don't remember this, as I said in the previous lecture, it's fine to just go ahead and rederive it using your product rule for y is r sine theta and x is r cosine theta. So let's go ahead and plug in here and figure out what our dy dx is going to be. So I'm just going to write it down again. So we're going to get dr d theta sine theta plus r cosine theta, and all of that is over dr d theta cosine theta minus r sine theta. So we know r and we know theta. Remember, our r was 2 and our theta was pi. So we need to get dr d theta. Remember, our curve here is r equals 2 minus sine theta. So that was the curve that we were given. R is 2 minus sine theta. So now we just need to get dr d theta. So we get dr d theta is, derivative of 2 is 0, derivative of sine is cosine. So we just get minus cosine theta. So plugging that in, we're getting minus cosine theta sine theta plus r cosine theta all over, again, our dr d theta was minus cosine theta, so now I get minus cosine squared theta minus r sine theta. And now finally we wanted this at the specific point where theta was equal to pi, and we figured out that r is equal to 2 at that point. So plugging in, we're getting minus cosine pi sine pi plus 2 cosine pi, again I'm just plugging in r is 2 and theta is pi, over minus cosine squared pi minus 2 sine pi. So now doing our calculations, sine pi we know is equal to 0, so terms with sine pi go to 0, and we get 2 cosine pi, which is minus 2, over cosine pi is minus 1. I square it and we get 1, and then it has a negative in front, so we get over minus 1, which is equal to 2. So remember, this was for calculating our slope m. So far we have that our slope m is equal to 2, and our point on the line we found to be minus 2, 0. So now I can use our point slope form, and we get y minus 0 is equal to 2 times x minus minus 2, or this gives us y equals 2x plus 4 when we multiply out. And now it's always a good idea just to go back up to your graph and see if this makes sense as the equation for our line. So we got y equals 2x plus 4 as the equation for our tangent line. So it does look like our slope, our line definitely has positive slope, so that checks out. And 4 as our y-intercept. Again, my line isn't drawn perfectly, but it does look like this is going to, our line is going to intersect the y-axis in a positive value, definitely greater than 2. So again, this checks out in terms of making sense. So to summarize, the steps here were to remember that if you want the equation of a tangent line, you need to get two things. You need to get a slope, and you need to get a point on the line. The point on the line we get by using x is r cosine theta and y is r sine theta. R we can compute from the polar curve, and theta we were given. So we get our point on the line. And then we need to compute our slope m. In order to compute our slope m, we need to get dy dx. And you either remember the formula that we derived for dy dx for a polar curve, or you can just rederive it as we did. So we plug in r and theta to compute dy dx. In our dy dx expression, we have two dr d theta terms. So we'll need to compute dr d theta, which again, we do using our given polar curve, r equals 2 minus sine theta. So in this case, we used our r equals 2 minus sine theta to compute dr d theta, and then from there we just plug in. Finally, we plug in theta equals pi, r equals 2. That gives us our slope. Once we have our slope, we can just use the point slope equation of the line to get our equation. And then again, it's always a good idea once you have your equation, go back up to your graph and make sure that your values make sense in terms of the slope and the y-intercept.